Okay, good morning. Welcome to
FamilyMath number 876.
FamilyMath 876. So this is a something I saw retweeted by John Cook's probability fact, and it's from our friends at Futility Closet, and it's called the paradox of the second ace. And would you mind reading what it says? Just these two paragraphs.
So it says, you're watching four statisticians play bridge. After a hand is dealt, you choose a player and ask, do you have at least one ace? If she answers yes, the chance that she's holding more than one ace is 5359 over 14498, which is less than 37%.
Okay.
On a later hand, you choose a player and ask, do you have the ace of spades? Strangely, if she says yes, now the chance that she has more than one ace is 11686 over 20825, which is more than 56%.
Okay. Do you know what bridge is, by the way?
No.
There's four players, and you deal out the whole deck, so everybody gets 13 cards.
Okay.
Right.
So you deal out the whole deck, everybody gets 13 cards. You ask someone, do you have at least one ace? So you ask one of the people, maybe this person over here. Do you have at least one ace? If she says yes, then the chances that she has more than one ace is about 37%.
Okay.
Strangely, if you ask, do you have the ace of spades? And she says yes. Now the chance that she has more than one ace is 56%. So this is called the paradox of the second ace. So I'd like to hear your initial thoughts on that. Go ahead.
Well, I'm wondering if this is true. Like, say if you ask for the ace of diamonds.
Okay.
Like, are they just spades that are special, or will this work with any ace?
Good question.
Well, maybe why it might be true is like it's special about naming that actual card instead of just one ace, like in general.
Okay. Does this surprise you
Yes.
that this is true?
It seems like you're kind of asking the same thing, almost, but the percent chance is higher if they have more than one ace. If you ask the ace of spades.
Okay. Does it surprise you that this is true?
Well, kind of.
Alright.
Because here you're asking for a thing, your initial condition is going to have a higher chance of being true.
That's an interesting point. Okay.
And you have a lower probability here. So you have and then here in this second scenario, you have a lower probability of having your initial condition met, and then a higher probability for your second condition being met. So maybe kind of averages out to be the same.
Interesting. Now you made a really neat point. It sounds like these questions are the same. Do you have at least one ace, or do you have the ace of spades?
Yeah.
Okay. In what way would you say these are the same?
Well, the ace of spades is at least one ace. So if you ask, like, if you ask these questions like at the same time, they would. If you have at least if they both said yes. So if you said yes to this question, then this question has to be true.
Wait, if you say yes to this
no, if you
question.
say yes to this question, this has to be true.
Okay, good.
So,
what's a time where you would say yes to this question but not yes to this question?
Well, if you had like the ace of diamonds, and then so you wouldn't have the ace of spades.
Okay. Any other thoughts you have on this?
No.
Not really.
All right. We are not going to calculate this today. That's going to be our project tomorrow. We're going to try to come up with these numbers, approximately 37%, approximately 56%.
All right.
But today I'm going to try to explore two slightly simpler problems as a starting point,
Okay.
Okay.
and see if we can make some sense out of them. Okay?